not as engaging if folks are spread out. So if you're here for a presentation, please drift closer.
All right, well, thank you everybody for joining us this morning for the panel on renewable heating. A conference about renewable energy wouldn't be complete without a conversation about how clean energy and building emissions play into the overall picture of reducing greenhouse gas emissions. So I think this is a really important panel, and I'm pleased to be up here today with Jennifer Green, from the who's the Director of Sustainability and Workforce Vitality at Burlington Electric Department, and Mark Stevenson, who's the owner and general manager of Vermont Energy Contracting and Supply. I'm Emily Lewis. I'm the director of the Climate and Energy Analysis Center at Acadia Center. And I'm going to kick things off today with some work we've been doing on a report called Clean Heating Pathways. So I will jump right in, and then Jennifer and Mark will follow, and then we'll open it up to Q&A at the end. We're gonna have to do it the old-fashioned way, so please come up to the mics if you have a question. And we will do it like that. So I wanted to talk briefly about Acadia Center before I jump in here. We are a nonprofit clean energy research and advocacy group. We are focused on the Northeast region. And the regional perspective gives us an opportunity to look at climate and clean energy needs across multiple states with lots of similarities, to share best practices and propose big picture policy solutions. Since we've been working in the regions for about 20 years now, we've helped realize $30 billion in energy savings and reduce emissions about 23%. Of course, we can't take full credit for all of that, but we like to think we helped a little bit along the way. Slide isn't changing. Huh. It's changing on my end.
Do you want to jump up? No pressure. maybe between us all, we can get it squared away. There we go. Right?
No, it's changing for me, but not up here. So strange. Those are just notes.
On the computer.
Yeah.
I wonder what happens if you do slideshow again. Zoom slideshow.
No.
Not actually in the room.
I'm feeling better now about my decision to not bring any slides.
I almost feel like wouldn't hurt to shut it down and then try again. Maybe.
Could try. I'm seeing slides here, and they can change when I flip them, but they're not changing on the main screen. Your slides?
Yeah, that's one presentation, wrong one though.
Wrong presentation. All right.
That's okay. Closer.
So which one? Which one?
This one here. Well, there you go. Voila.
But it, yeah, I just can't see it here. I think we can make do. I will. Yeah. I will look over here and hopefully, okay. Okay, sorry about that. So Acadia Center, we're working across the region to really bring about policies to stem climate change and advance clean energy to help consumers realize the benefits that come along with reducing their emissions. So along the way, Acadia Center has done a lot of data and analysis to support our advocacy efforts. And in 2017, we released a report called Energy Vision 2030, where we looked across all the sectors of the energy system to understand how markets must change to reduce emissions 35 to 40% by 2030. And buildings was a key part of that. And so we wanted to dig deeper into the opportunity for advancing clean heating in the region. The Northeast in particular has a great opportunity to reduce emissions in the building sector because we rely 30% on fuel oil for heating our buildings. If you total up all of the fossil fuels we use, it's about 85% of homes in the region. So there's a great opportunity to reduce emissions, but along with that, I don't have to tell anybody here that New England has really, really cold winters, and what comes along with that is high costs for winter heating, and it's on the order, on average, of about $1,000 to $2,500 annually per person. So if we can both reduce emission and start to reduce costs for consumers, it's really a win-win situation. And by doing so, we can help address the 30% of emissions that come from the building sector. So I'm not sure how familiar people in the room are with heat pumps, but they are commercially available and widely used. Around the world, heat pumps have been used for a long time. In Canada, about 7% of home heating comes from heat pumps. So our neighbors to the north, where it's even colder, are already using them significantly, so we know we can use them here. They're highly efficient, about 3 times more efficient than the best natural gas systems out there. So if you're using less energy to generate heat, that costs less money because you're buying less fuel or electricity. I talked about how they're effective in the cold winters here. They also are zero emission and chimney free. So when you have a fossil fuel heating system in your home, you're combusting that fuel, which creates things like carbon monoxide and nitrous oxides that have to be exhausted. And if they don't exhaust properly, they can build up in your home and trigger things like asthma or other hazards. So heat pumps actually avoid that situation as well, which is a health and safety benefit. And they're available in a lot of different options for your whole home heating or partial heating of your home. So a lot of people just install them in a highly used area like a living room to improve comfort in that space and also reduce their overall fossil fuel consumption. And so there are a lot of benefits of heat pumps. I wanted to dig deeper into the pollution reduction opportunity here. So this chart shows the avoided emissions when you switch from a fossil fuel to a heat pump. So the 3 fuels, I don't know if you can read it, red is gas, yellow is oil, blue is propane, and you get the biggest reductions from converting a whole home from oil to a heat pump. Next is propane, and third would be gas. But importantly, you can also reduce emissions quite a bit from these partial home heating solutions. So even if you're just putting a heat pump in that one room of your house, you can really harness quite a bit of emissions reductions without, overhauling your whole system. Coming along with the heat pumps, I talked about the reduced emissions, reduced fire risk, reduced thermal stress. A lot of sensitive populations can benefit by improving the comfort of their home. You're reducing the risk of hypothermia and hyperthermia because heat pumps can both heat and cool. And then finally, by doing these HVAC improvements, Massachusetts was looking at quantifying these benefits. And they found that $265 annually could be saved by low-income households by doing these type of HVAC improvements because of the improved health and safety. So there's a significant monetary opportunity there as well. And in addition to the health and safety benefits, you also get the fuel cost savings. So we analyzed what it would save consumers from switching from oil and propane, again, yellow and blue, to heat pumps in both whole home and partial home retrofits. And the biggest savings we're seeing is coming from switching from propane to a whole home heat pump. You could save as much as $1,600 annually by switching. But again, you harness that fuel cost savings even if you're doing the partial home retrofit on the order of $400 to $800 a year. And so with these annual savings, you're looking at a payback period of 5 to 11 years. But those payback periods can be reduced to the extent you are having consumer benefits as well. And I think, consumer incentives as well. I think Jen and Mark are going to talk about that later. I don't have the savings up here from switching to gas, but they do exist. They're just smaller. But the biggest thing to note is that you harness greater savings as a consumer by switching from oil or propane to a heat pump rather than switching to gas. And so when you're doing so, you're also preventing expansion of the gas network. The cost of the pipes in the ground, you're avoiding those costs as well. And so I'm got the 3-minute marker, so I'm going to go through these pretty quickly, but we've looked at a lot of the barriers to heat pump installations and how to overcome them. So one of the primary reasons heat pumps don't get installed is because consumers don't know they exist, or they're hesitant about the technology. So educating both the consumers and the vendors and installer community, because when your heating system breaks, the first thing you do is you call up your installer to come fix it. And if they're confident with recommending heat pumps, you can make consumers more knowledgeable and confident in them as well. Coupling heat pumps with home weatherization can maximize savings. When you tighten up the home, you lower the amount of heat you need to heat it because there's less escaping. And so the less heat you put into the building, the less it costs you. So when you lower those consumer costs, you make heat pumps even more attractive. So coupling heat pumps with weatherization really is a good benefit for consumers. The residential new construction market is another low-hanging fruit for getting at heat pumps. It's the lowest cost option for a heat pump rather than doing a retrofit. If you do it at the time of construction, that's the most efficient way to do it. And so every home you're building, you're also locking in that heating system for the next 15 or 20 years. So to the extent we can build these homes right away with heat pumps, that's a good policy move. And you can force that happening with things like building codes or incentives for builders to build new homes with heat pumps. Smart electricity pricing is another way to reduce operating costs because electricity is the fuel of the heat pump. So if you can look at things like electricity rates, lowering electricity rates, you can lower consumer costs. And so when you are a residential customer, your electricity costs the same usually, no matter what time of day you're using it. But the system costs actually vary quite a bit. In the middle of the summer, electricity costs are very high when everyone's using their AC compared to the middle of the night. So if you pass those cost signals on to your regular customer, they have the incentive to use the heat pump at lower cost hours. So when they have a lower cost hour for heating, they can use their heat pump at that lower time, and it saves them money. There are also incentives within utilities to promote natural gas. This is less the case in Vermont, but sometimes you have utilities that own both gas and electric assets. And so utilities make more money by adding new gas customers rather than adding heat pumps to already existing electric customers. So removing those incentives for utilities can help promote heat pumps. And then finally, lots of states and even cities like Burlington have plans to reduce emissions by certain years in order to meet our climate goals. And so you need to deploy heat pumps at a certain rate in order to ensure you're going to meet those goals. And so while most states have incentives for consumers to install heat pumps, we need to make sure those incentives are driving the customer behavior we want to see and the rate of heat pump conversion we want to see. So we need to be aligning those state policy objectives with the incentives that are available to customers. And so with that, I'm going to hand it off to Jen, I think,
Great.
next.
Okay, thank you. Let's see how this goes. We have more luck now. Let's see. Okay. It's like deja vu all over again. Voila. We think. Nope, frozen. All right, Sebby, don't leave us. Well, I'm going to go ahead and maybe you can prime us up. So I feel like my job, and I appreciate Emily asking me to participate in the panel, is to bridge the gap between sort of Emily's bigger sort of picture analysis of what's going on in the Northeast, you know, how heat pumps are applied, what their application might be, and how Acadia's work is helping to advance sort of building electrification throughout the Northeast and maybe even Canada. Oh, thanks a lot, Sebby. That's great. So I'm really excited to hear from Mark, who's going to tell us what's happening on the ground, particularly Mark's work in Burlington and what the heat pump deployment scenario is looking like, adoption rates, et cetera. But before Mark, I'm going to just quickly tell you, again, sort of as a bridge presentation about some work that we're doing in Burlington. And I appreciate you being here, and do want to apologize ahead of time to my colleagues who have heard about the Net Zero Energy Roadmap probably more times at this point than they'd like to admit. But we're really excited in Burlington that in September, we launched our ambitious goal of becoming a net zero energy city in the thermal and ground transportation sectors by 2030. And this builds on our portfolio of 100% renewable electricity. And most of you are likely to know that this came about with the purchase of Winooski 1 in 2014. So now that we have this sort of clean electric platform on which to build, we're excited to take it to the next level. And again, that's a big piece of that will be building electrification. Oh, it's really not behaving. So I'm gonna try to go with what's on the screen. So we hired a company by the name of Synapse Energy Economics. They looked at our complete energy portfolio in Burlington and looked at what our trajectory would need to be to get to net zero energy by 2030. And at the end of the day, this is what the pie looks like. When you take out transportation, and in particular, people that are driving from out of Burlington into Burlington, it turns out that building electrification is the most important piece of our path to net zero. That's going to be 60% of the work that we do. And so really awesome that we have teams like Vermont Energy on the ground sort of helping us move this forward. I would be remiss if I didn't mention that sort of following the building electrification emphasis is going to be transportation, and in particular, the electrification of our transportation sector. We're going to need to get everybody out of their internal combustion engine vehicles into electric vehicles. We're going to need to tap this District T project that we've been talking about for quite some time. And then last but not least, of course, is the emphasis on reducing vehicle miles traveled. But for the purpose of these next few minutes, I really want to talk about building electrification. Oh, and I apologize, it's freezing. So without using slides, I'm going to tell you that from a residential and commercial space, this is not going to be easy, particularly residential in Burlington. About 95% of Burlingtonians heat their homes with natural gas. And, you know, given some of the challenges that Emily mentioned, this is going to be particularly tough just from a cost parity perspective. We'll hear from Mark, though, that the cost doesn't always play into why people are switching over to heat pump technologies, and that I find very encouraging. What I can tell you about our roadmap, though, is thankfully, to Mark and others, we are seeing that people are replacing their systems before they need to, and that's going to be a fundamental piece of actually getting to net zero. We're not simply waiting for systems to die, traditional sort of gas furnaces, for example, to reach our net zero energy plan. We're having systems switched out ahead of time, and that's a good thing. In the commercial space, I'll tell you that we're going to need to weatherize 50% of our commercial space and also fully electrify. This is going to have to also happen faster than the rate of normal turnover. One of the interesting pieces about the commercial sector of our roadmap is that we're seeing that cooking, and industrial cooking in particular, is going to need to switch to electric. So this is a particularly big challenge, but also an opportunity with UVM and the hospital. And I'm going to leave it at that with a frozen slide deck and invite you to go to the Burlington Electric website to look at the roadmap. And again, I think the message that I leave you with is that we're going to need to electrify our building sector. We're going to need to electrify quickly. We're going to need to electrify before the normal sort of rollout period would normally transgress, i.e. before systems fail. And we're going to need to do this in tandem with our partners on the ground, sort of Mark's company, for example. So Mark, I'm going to turn it over to you. And I think, let's just turn this off.
Yeah.
Nope.
I don't think so.
Oh, there we have it. Well, I know Mark is not.
I can give your presentation now, but the slides are working.
And we'll switch it up.
So I don't have any slides, so you can just look at me, or you can look at that. But my name is Mark Stevenson. I work with a company called Vermont Energy in Williston, Vermont. They're a full-service mechanical contracting company. that services Northwest Vermont. The niche is quality mechanical systems, so that's efficient, dependable, serviceable systems. I want to start just to say, kind of dovetail out of Jen's comments about Burlington, and just talk for a minute about a particular project that occurred over the last couple of years. If you haven't been down to the Community Sailing Center, which is on the lakefront in Burlington, it's a great example of what the goals are and what people in this room are interested in doing. The organization, the Community Sailing Center, partnered with Burlington Electric, LN Consulting, also Second Law consulting firm, and Vermont Energy. We were involved as well. And they basically looked at they needed a new building. They were in an old facility that was about to get torn down. And they had the opportunity to use natural gas, but they also thought, well, what if we looked further and could we do this with a net zero energy? We're a long-term investor. And they did decide and went down the path of doing renewables. It's a net zero energy project. So the real beauty of this project and the real the way in which this project came together was Burlington Electric's energy modeling program. So that's to take the building originally and not just say, well, we're going to plug in this particular, put solar on the roof, or we'll build, X shell with a certain amount of insulation in it. The modeling really helps you find the sweet spot between the building shell, the building envelope, the square footage of solar on the roof, how much potential solar you can generate from that, heat pumps, energy recovery, ventilation, electrical load, and really dial in exactly what you need to do to make it a successful project. And so Burlington Electric, that modeling really helped the developers find the right balance between all those pieces. And then in the end, came back and assessed how the project was doing and helped them tweak to make some adjustments to make that a successful project. So that's a great opportunity for new construction available. It's happening in Burlington, happening all over the state. But most of what we need to really pay attention to are existing buildings. And what I'd like to do in my short presentation here is just kind of give you a street view of the air source heat pump market and how it's developed in Vermont over the last 20 years. I'd like to start by mentioning that my wife and I were recently in Southern California. And I love the coast of Southern California. We're traveling up and down the coast. The beautiful rocky shorelines, the waves coming in. And I particularly enjoy watching the surfers out there. What does this have to do with heat pumps in Vermont? But give me a minute. So surfers spend most of their time sitting on a surfboard, looking back, waiting for a wave to come. And that's where we were 20 years ago on the industry. People didn't really know it. Homeowners didn't know it. Building owners, contractors didn't know it. People were calling us. People were looking for, at that point, it was really air conditioning. Getting a little hotter, I'm getting older, my building's not well constructed, it's hot, I can't sleep. Get a call, I'd like to air condition my house, or I'd like to air condition my office. And we would say, well, do you have air conditioning now? No, we don't. You get there and they've got 3 window air conditioners and 6 ceiling fans. Well, there is an AC system there. Everybody's got an air conditioning strategy. But there was this new product available. You could hang this panel on the wall, run a line to the outside, put a set of box down, really simple. And voila, you've got quiet, efficient, comfortable air conditioning. It's a permanent part of the structure. It's not a throwaway technology. And that was really the beginning. And it was slow, but it was catching on. People would make $5,000, $10,000 investments. That's a sizable amount of money for something that was just brand new. 15 years ago, the heat pump was introduced or brought into that line. So people now, this was not a cold climate heat pump, this was a standard heat pump. So now we not only had cooling option that as a contractor we could offer people, but hey, you can heat in the, in the spring and the fall. Well, that sounds great. So the product began to pick up a little steam. 10 to 12 years ago, the hyperheat or cold climate heat pump was introduced to the market. The initial applications were contractors building extremely energy efficient homes with clients who were seeking this out. They'd done their research, it was a new technology, it was emerging. They're going to get on board before everything was quite together. They were going to be the pioneers. And we're like, well, if you guys want to be the pioneers, we'll put it in. We're okay with that. If it doesn't work out, you were involved in the decision. And then within the next, 4 to 5 years, and I will pick a year of 2014, when our company in particular started to work with SunCommon, who's a big player in REV and a big player in the solar market in Vermont. We partnered together. SunCommon decided that, hey, we could sell a lot more panels if our clients not only had basic electrical load, but if part of their heating load were done through electricity, we could put in a bigger system. We could provide a better service to our clients. So in 2014, our business jumped by 15 to 20% because we had a relationship with a solar company. Totally made sense for them. So the waves are starting to get a little bigger now. And so how do we get to this point and how do we move forward? The industry is starting to go. So back to Southern California, we're looking back there and now there's a wave coming. We're on that wave, we're all excited. We get up and realize, yeah, it's not that big a wave. Well, maybe there's another one coming, but I'm going to ride this one in the meantime anyway. And the question is, how do we move forward? We've got a product that is viable, but we got to put some other pieces together. So the next step really is partnerships. So the manufacturers wanted to develop partnerships with wholesalers and with contractors. And in order to have a partnership, they're going to expand what they offer. So technical expertise, the backup, training facilities were established in New England. We're going to have to really ramp up to get this technology moving and to back the industry. And at the same time, the contractors and the wholesalers were dealing with an industry that was kind of rampant with products from good manufacturers that frankly just didn't work. Not necessarily heat pumps, but there were some issues in the heat pump market, but modulating condensing boilers, there's a lot of stuff that people just got held, holding the bag. So if you're going to really get on board with an industry, you've got to have a commitment. So the manufacturers, Mitsubishi, Daikin, Fujitsu, they wanted a relationship. And we said, look, if you want a relationship, we need a commitment. If we're gonna live together, we got to get married, right? So manufacturer said, okay, we'll give you a 12-year warranty. So that was our commitment. And that is, you know, now you can go for it. Now you can say, yeah, okay, all right, we're going to live with this. And we're not worried that 5 years from now, we're going to be yelling between the building owner, the homeowner, and the contractor or the supplier at that point. You know, 6 years down the road, nobody wants to spend $2,000. And we don't know. We don't know if this stuff's going to work or not. So now the industry has made a commitment and we're moving forward. I did some exhaustive research yesterday. I called up my supplier, and while he was on the phone, we came up with a few numbers that I thought would be interesting just to kind of illustrate where the industry is right now. Year to date, heat pump sales, this is one supplier in Vermont. They're the major supplier of heat pumps in Vermont. Don't write these numbers down because this is a off the napkin research. But they'll tell a story. Of the heat pumps sold today, air source heat pumps, 80% are hyperheat. 15% are the regular heat pumps, not hyperheat. And 5% are cooling only. So in 20 years, we went from 100% cooling only to big switch. Now, not everybody who has a hyperheat system installed bought it for heating. But I can tell you that all those people are going to use it for heating. And what the industry has done by providing incentives, utilities, the education, is they've taken away the difference, the cost difference between a standard heat pump and a regular heat pump, or and a cold climate heat pump, so that now the contractors and the wholesalers who have a commitment now, they've got a ring, they got a commitment, they got a 12-year warranty, they can feel great about installing the hyperheats. And so we're getting hyperheat equipment out there at a big rate. So I made another phone call to my Mitsubishi rep, and I said, "You got a minute? I need some research." So we came up with these numbers. 2019 year to date, Vermont's heat pump sales are up 21%. Again, don't write this down because this is not scientific, but it illustrates the point. These are close enough. Massachusetts up 38%. New Hampshire, sales up 38%. Connecticut, sales are up 50%. Maine, 34%. New York, 43%. Rhode Island, 70%. Those are heat pump sales in 2019. Now, since 2014, sales have been growing at a pretty geometric rate. What's happened is that in the last couple of years, a lot of rebate programs have come about. And that's pushed these numbers way up. Now, some places like Rhode Island and Connecticut, it's up 50%. In Vermont, we're up 21%. There are more heat pumps being sold in Vermont than they are in Connecticut. They're kind of slower to get on the bandwagon. So now they've stepped in. They're moving quickly right now, but the volume still isn't going. So the numbers don't tell the whole story, but what they do tell is that the industry is moving very quickly. So back to Southern California. So turn around, we're looking for the wave, and oh my God, here comes the big one. And right now, I tried surfing once or twice. I failed miserably, but I can just sort of, I remember the idea that wave's coming, and you're lying down on the board, and you try to push yourself up, and you stand up. And right now, we are standing on the crest of a very big wave. And this is the most exciting part because, in 2 seconds, you're probably going to fall and smash your head. Or you're going to get to ride that big curl that we've all seen in the pictures of the movies of somebody riding inside of a curl. And that's where we are. You know, we're standing on the edge of that big wave. And the numbers are moving very quickly. So the takeaway in this really is that we've got, you know, we're a more conventional fuel, plumbing, and heating company. Started out as a renewable energy company 35 years ago, solar and wind. But that quickly fell away. That technology, that original technology died. Got replaced with what we're dealing with today. But the kinds of people that are involved in the trade, the HVAC trade, aren't people who grew up with laptops and computers. They're people who turned wrenches, who changed oil filters, you know, changed oil nozzles. The industry is changing very quickly. So the way in which this is moving forward, and the way it has to move, and the way it really is moving forward, are these partnerships, which is unique in the industry. It's the manufacturer, the wholesaler, and the contractor getting together and saying, let's put together a marketing plan, let's share in that, let's educate each other, let's create educational facilities throughout New England. And this is really regardless of, you know, of which manufacturer. They're all doing it. Let's get committed by providing some of the best warranties in the industry. And the air source heat pump, you know, people keep asking me, well, are you doing this kind of heat pump? You doing that kind of heat pump? You know, whatever. There are a lot of products out there. There are a lot of heat pump products out there which are going to develop, but they haven't gotten all that together yet. They don't have the educational facilities. They don't have the, you know, we need companies with muscle behind them that can't fail. They're committed to the industry. Our install and service techs need to retool, need to retrain, where we've got to bring in new, younger people who are maybe more excited about becoming tech savvy or are tech savvy. Customer expectations are on the rise. We were installing heat pumps or mini splits for people for air conditioning, and, you know, you'll call me on Monday, we'll be there and we'll get, you know, we'll set an appointment for you for Wednesday. Well, if you're going to be doing central heating for people, then you need to, people all of a sudden are expecting you to be there right away. You know, if you're going to make a commitment with this company, you want a relationship and you want someone to be able to be there right away. Well, it's not quite the same. If your laptop stopped working and you're at home, do you expect to call somebody up and have somebody over in an hour to your house and repair that laptop, and then 3 hours later you're back on your laptop again? That's not going to happen. We're asking, we basically have a computer that's sitting in your yard, and we need to figure out how to make that work. So the expectations, customers' expectations are on the rise, and the way in which we interact with clients with heat pumps is going to change. So companies are retooling, redefining emphasis. Oil's disappearing. Propane, which kind of filled this hole and has been expanding rapidly, is probably the next target. It's expensive. That's where a huge part of our clients are. They're propane. This is, you know, they're paying an arm and a leg. And natural gas. More and more clients of ours are people who are on natural gas, and they have multiple reasons why they would want to make this investment. But I can tell you the industry is moving extremely quickly. Manufacturers are expanding options. So pretty much the tools that we have to do any building are there now. And the efficiencies are improving. There are bumps in the road, don't get me wrong. This is not a panacea. It's not going to solve every problem, but we're getting there. And this is one, this is one piece of technology. When I was doing my exhaustive research, I also found that, interestingly enough, year-to-date 2019 in Vermont, for one supplier, heat pump domestic water heaters in New England, up 4% sales in 2019. In Vermont, down 3%. Huge opportunity. If we're so successful with air source heat pumps in that market, we have a huge opportunity with heat pump water heaters. Manufacturer expanding controls, or expanding options, improving controls, responding to field studies, improving efficiencies. So we are back in California. We're on the crest of that wave, feeling very excited, feeling great, and looking forward to the future. That's what I got. We'll open it up for questions. Mahalo.
All right, I noticed that we are cutting into everybody's break time, but I do want to open it up to the floor for questions. If anybody, I see a hand right here. Do you want to come? I think there's a mic right there. We can probably hear you better.
Yeah, I had just a couple of comments and questions. One, I'm wondering if Burlington Electric is taking a look at running the pipe that's been talked about for 20 decades, 20 years, 30 years, 40 years, to bring hook up McNeil to the hospital and the college, the university. And one of the points I want to make is, it seems to me that sometimes when we're talking an example of switching people into electric cars, if we do 1,000 electric cars at 35,000, which is around the cheapest bolt, we're talking $35 million. So what do we get for that same amount of money if we do the McNeil hookup? Norwich University, for instance, went to wood chipped heating system, and they displaced 1 million gallons of oil a year at a cost of $5 million. So I think in many ways we have to see how we're going to use our limited capital to take the biggest users of fossil fuel offline. And I am a little surprised that biomass wasn't on this panel to be talking about the opportunities there, which are, and there's a misnomer that if you burn wood, that you're negative to the CO2 issue. But the report, only one that's really been out there, is dealing with generation, large-scale generation, which is very inefficient, versus thermal heating and cogen for commercial, industrial, and institutional, and pellets for home. Thank you.
Sure. So I'm going to answer your question about district heating and where we are. And to your point, we've been talking about this for quite some time. We just finished a contract or a relationship with Corex out of British Columbia. And I can say, without knowing much of the details myself, that we're probably closer now than we've ever been to a yay or a nay. And please stay tuned. But to your point, I mean, it's an important piece of the roadmap. And if we can't tap in to what's available, what we think of as sort of the negative externality of McNeil, so the steam, then getting to net zero will be all that more challenging.
Is there, well, we can take one more question probably, and then we'll turn it over to the break.
I just wanted to ask about the comment in the first presentation that related to pricing. You're talking about smart pricing, and want to know what that looked like. And I think it was in the context of promoting specific end-use technologies, but I could have clarification there.
Yes, sorry, I was sort of rushing through. So I was talking about smart electricity pricing, specifically time varying rates. And so that's where you're pricing electricity higher when it costs the grid more to produce that electricity, and then having lower consumer prices when it costs less to produce that electricity. So often it's peak periods during the day and then lower periods at night. And so when you're heating at night, you can take advantage of those lower cost rates. And it's not perfect. So that's where home weatherization comes in, where you could potentially have a very tight home that you're preheating or pre-cooling during those lower cost hours, and that heat or coolness is staying in your building, so that you're taking advantage of it. And it lowers the operating cost of the heat pump in that way. Those rates also are advantageous to electric vehicles because you have such a flexible, your charging load is so flexible, you can charge at nighttime during those low cost hours. So moving towards these time varying rates can really be advantageous to electrification as a whole, and is just another tool in the toolbox to advancing these clean energy technologies.
Maybe I could just add from a
Please.
Burlington Electric EV standpoint, if you're a Burlington Electric customer and you're charging at night during the off-peak time, it's the equivalent of about 60 cents a gallon. So yes, if you can apply that same technology and off-peak system to something like a heat pump, then we're really starting to see some advancements.
All right, great. Well, thank you, everybody. Sorry for going over time. We'll let you have the rest of your break back, and take a minute to thank everybody on the panel.